See if I can share here. Can you see my screen?
Yes, I can.
Okay. All right, well, I'll go ahead and get started then. So to introduce myself, my name is Steven. I'm an application engineer here at EAC. And a lot of my job consists of more on the technical side of things. So a lot of what I do is I talk with customers and perform demonstrations for them, kind of figuring out how our solutions, how PTC solutions can help their company and help them grow as a company. So today we're going to be talking about model-based definition. And I know it's been a topic that's kind of been hot recently in industry, and that's for good reason. So we're going to talk about why we want to use model-based definition and how it could be helpful for your design process. Now I'll be kind of starting off in a presentation mode. I'm going to be going through a few slides. I'm then going to go into Creo, do a live demo for you guys, and then end again with the presentation. So for our agenda today, we're going to be talking about what is model-based definition, why do we want to use model-based definition, some of the helpful tools that PTC has to help kickstart you with your MBD journey, and then we'll talk a little bit about model-based enterprise and kind of what that looks like as well. So what is model-based definition? And really the best way I can describe it is taking our 3D model and having that become the single source of truth for our product and manufacturing information. And it all starts with an annotated 3D model. So with MBD, we're trying to use this model with annotations to replace the 2D drawing as the source of our product information. So let's talk a little bit about product definition processes, kind of the traditional versus digital with MBD. So traditionally, what companies, probably about 95% of the companies that I work with, the 2D drawing is the legal asset that describes and defines our product. And really the reason for this is because before we had 3D CAD, 2D was kind of the standard format and the primary engineering deliverable. And for many cases, like I said, it still is today. And then when we talk about MBD, we kind of talk about digital transformation. So with MBD creating that single source of truth in the 3D model, that 3D model is going to include all of our dimensions, tolerances, GD&T, notes, all that other information that would be in the print. But if we have the model that has all this information, why are we still managing and creating that separate asset in the 2D print, right? So really what MBD is going to do is it's going to reduce waste. It's going to decrease lost time and effort actually creating these 2D drawings. We're going to minimize rework and out-of-sync information. We're going to eliminate the need to track and manage those additional assets and information. And finally, reduce errors due to the misinterpretation or poor communication of those two different sources of truth. And I think it's easy to say, right? If we have a person who's maybe out on the shop floor and they're trying to envision what the product actually looks like, if they try to envision that from the 2D print versus actually spinning around a model and seeing what the model looks like, I think it's easy to say that, it's much easier to interpret, to interrogate a 3D model versus a 2D print when you're trying to figure out what this model looks like, what it does in application. So we have our 3D annotated model, and this model is fully semantic. So that means that our dimensions, our notes, they're actually referenced by actual geometry, which helps us with downstream activities. It's going to help us with faster product development, faster manufacturing and inspection, reduced errors and nonconformances, And just general feedback, to throw some numbers on the screen here, some feedback from PTC customers. What they're seeing while using MBD is 40% faster documentation creation, 60% reduction in first article inspection time, and 90% less product nonconformances. So that alone kind of speaks to the power of model-based definition. And the nice thing is you don't need any add-ons. You don't need to pay any additional cost to use model-based definition. It's all in the core of Creo Parametric. So PTC also has some helpful tools to help kickstart the MBD process for you and your company. And the first one is GD&T Advisor. So GD&T Advisor, what it really does is it helps with the efficiency and creation of your geometric tolerancing, as well as the validation for that GD&T creation. So there's a wizard-like dashboard to help guide the user to the correct application. It's a feature-centric view of the GD&T, and then we're going to have not only our feature tree but also an advisor tree that displays messages to inform and guide the user to make sure that they're applying their GD&T to the correct standard. Another tool that I'm going to touch on today is Creo View. And if you're currently using Windchill as your PLM system, you'll know that Creo View comes free with that PLM system. And the nice thing about Creo View is that we can leverage model-based definition with that. And anyone can view and interrogate these models and documents without needing that native authoring application. So what Creo View does is it takes that heavyweight, heavy data model, it converts it into a lightweight viewable that we're allowed to do a few different things. First, we can interrogate the design, we can take measurements, we can calculate mass properties with that, all with these automated tools with Creo View. But more importantly, in my mind, we can create digital markups. So instead of having that 2D manual handoff print process where we're taking our actual manual prints and we're taking a red pen, and we're marking that up, what we can do is we can do this with Creo View and capture all of that digitally, being able to track and manage those markups in a much more secure and efficient way. All right, so with that, I'll go ahead and move over to Creo. We're going to talk about model-based definition, GD&T Advisor, and Creo View. So we'll start with Creo, and right now I'm working in Creo 8 here. And the part that I'm working with here is this bracket, and it's a casted part, and then it's machined to create that final product. Now, with model-based definition, what we really want to capture is all the annotations that would regularly be in a 2D print. And we can do that by breaking it out into different combination states. So if I scroll through the tabs on the bottom here, these are all of our different combination states. So they represent different areas of notes, annotations, things like that, stuff that you would normally see on a 2D print. So let's start with the first one. And this is this combination state kind of represents some of the company information. So we see our company information on the bottom left here. We have an ITAR notice at the top, and then we have a proprietary information notice on the side here. So stuff you would maybe see in a title block of a 2D print. For this next state, we have a sitemap for this product. So we have kind of a labeling that labels what you'll see in some of the different combination states for this. So you can see we went through the default first combination state, now we're in the sitemap, and it kind of lays out what we'll see in the rest of the states. It also explains some of the features that are being machined after this part is casted, right? So we have our holes, backside holes, our counterbore holes, our clevis slot, clevis holes, and base holes, right? So moving on to the titles here. This is something that you might see in maybe a table, right, on the 2D print, where we have our design signatures. And these are parameters very similar to what you would do in a 2D print. You would add your designer name, designer approval, any signatures that you may want. We can do that just as notes right on this model itself. Next, we have our properties. So this would be our material information. You can see that this is a aluminum alloy. We can place our material finish in here, material engineer, and then some mass and density calculations as well. Number 5, we have just some general notes, and this is probably what you'd usually see on the first page of a 2D print, right? We have our dimensioning and tolerancing notes, some post-manufacturing process notes like removing all burrs and sharp edges, reference to our cleanliness spec, and things like that. Now moving on to the next view here, we're going to start getting into some of the features and annotations. And the nice thing about MBD is that we can break those up based on the different features. So instead of trying to cram everything into 1 or 2 pages on a 2D print, we can break it up so that it's very easy to understand, very easy to interrogate how this model, how this product is being manufactured and how it's being defined. So the first one is our datums here. So you can see laid out very clearly, we have our 3 datums, as well as some geometric tolerancing that relates to them. And now these next, however many there are, 1, 2, 3, 4, 5, kind of define, these next states kind of define the features, right? So here we have our base holes and the dimensions that go along with those. Our backside holes, right? Clevis slot, clevis holes, and our counterbore holes that go through the top. We can add sections very similar to a 2D print as well. Now that we kind of have an overview of what this product looks like, we can start explaining how to go about creating these different combination states, how to go about managing them in kind of a easy to interrogate way. So in order to create a new combination state, let's say I wanted to create a new one, we'll go up to the top left here and click new. And you can see it added that tab in here. I'll go ahead and drag that guy over and rename him to MBD 7B, for example. Now notice when I click through these combination states, it saves the orientation of that. Even if I spin this guy around, come back to him, he's going to maintain that same orientation. Now to do that, let's say we want to have a specific orientation of this guy, something like this. All we have to do is click on this update button. And now if we spin him around, maybe exit and come back to him, he's going to maintain that same orientation. So let's go ahead and add some annotations, and we'll start with a note. And really the main difference between annotating in the 3D model versus the 2D model is making sure that you have the correct annotation plane selected. And all of the annotation planes are displayed on the top here, and you can see kind of a grid light up that displays what plane you're working with. So for this note, we're going to have it on the bottom plane. We can go ahead and add a note with a leader on here. Let's say we just wanted to add it to this surface. I'll just say sample note. Now it did show up backwards, right? And that will happen sometimes with 3D modeling, but it's very easy to change that. We can just change the orientation and flip that to the right direction. Now, one thing that sets MBD apart from a 2D drawing is that these notes, these annotations and dimensions can be directly referenced to actual geometry within our part. So if I click on this and I open up our semantic query, we can see that this note is referenced by this surface. Okay, so this note, whatever it may be, is going to reference whatever surface we have selected for this. And we can add more references to this as well. So let's say we wanted to do that. We can go ahead and click on that. Let's say maybe I wanted to add this surface as well, maybe a couple of these, just for example here. right? And now if we click on our semantic query, we can see all of the highlighted surfaces that are referenced by that note. Okay, so annotating in MBD is very similar. Let's go ahead and do a couple dimensions here. So we have our counter bore holes, we have the depth, but we still need to define the diameter of these guys. So what I'll do is make sure that we have the correct plane selected. And I'll go ahead and select on the surface of this hole and create that dimension there. Now we're going to give him a tolerance. Let's just say we want to give him a tolerance of 0.2. And we want to reference all 4 of these holes, right? So I could add the 4 times additional text in here, which I'll do first. But I can also actually reference this annotation with the actual geometry. So let's go ahead and do that. I'll click on our annotation here, and we'll go ahead and select all the correct surfaces that have to do with this dimension. Okay, so now if I open up my semantic query and click on this, you can see that all the correct holes are selected for this, or referenced by this annotation here. All right, and then of course, similar to 2D drawings, we can also add geometric tolerances, so we'll go ahead and do that as well. And we're going to do a perpendicularity for this guy. Give it a tolerance of 0.2. And we're just going to reference our datum A here to create that. Okay, so just to recap what we've went over so far, we are able to create annotations through these combination states. Each state is going to represent, different information about the product, whether it's dimensions or actual notes or geometric tolerance or anything like that. And if we actually wanted to manage those combination states, we have that ability to do that in the view manager here. So let's say for maybe this one, I could go and edit the definition of this guy. I could pick a simplified rep. I could pick a cross section if I'd like to, change the appearance of him, and things like that. Okay, so let's check out GD&T Advisor and see some of the power of that with connection to model-based definition. So to get to GD&T Advisor, I can open it up here in Applications. And if you're not familiar with this, I'll kind of do a brief overview of GD&T Advisor. So we have our feature tree, very similar to regular Creo. But the thing that's added with GD&T Advisor is this advisor tree. So this advisor tree is going to have messages for us to interrogate and look at. So there's 3 types of messages. There's an information message, a warning message, and an error message. And according to the standard that's selected, and if we go to edit properties, we can see that the tolerancing standard that we currently have selected is the ASME Y14.5 version 2018. So according to that standard, GD&T Advisor will analyze our annotations on our model. It will check that back against the tolerancing standard, and then give us these warning or error messages according to that. So the first one we can see here, let's address the error messages first. So it says the specified geometric symbol is not allowed, and if we click on that, it'll highlight that geometric tolerance that we created. And if we wanted to get more information on that, we could say more help, and it'll tell us, exactly why this is not allowed, right? So we have that kind of that learning feature as well with GD&T Advisor to explain to you why these are not allowed, right? So what we can do is we can go ahead and fix this. So I'm going to take this pattern of our holes and I'm going to edit that in our feature tree. Now this part is pretty cool, and I really like GD&T Advisor. I think it's a great tool. If we open up our symbol for this, right, the symbol is what's causing the error here. I don't even have the option of picking perpendicularity. So what GD&T Advisor will do is it will recommend or tell you exactly what symbol to use in the case of this model. So it's saying we need to use position. Awesome. We can use that. We can still maintain our maximum material condition. And this check mark changed from orange to green, indicating that this symbol is good to go. We can go ahead and create that. You can see it automatically updated our geometric tolerance symbol and got rid of our error message over here on the left here. Now, another nice thing about GD&T Advisor is that at any time we can see the constraint state of our model. So if we click on our show/hide constraint state, we can see how this part is constrained. And we have our constraint state legend at the bottom left here, indicating that the green is fully constrained, yellow is partially constrained, gray is unconstrained, and our blue is constrained by a surface profile in note. So we can see that some of these surfaces are constrained fully, but we have a lot of surfaces that are not constrained at all. And we actually have a warning message here that says that, right? Some of the surfaces of this model are not constrained. So how do we address that? So what we can do is we can go to Edit Properties. And let's say we wanted to add a general profile note that says, unless otherwise specified, the general tolerance applies to all of our surfaces. So we can give that a tolerance, and I'll give it a tolerance of 0.3. Go ahead and accept that. And now we can see that all of our surfaces that were previously gray are now blue, right? And then, of course, we could add an annotation. We could add a note on the top here that says exactly what we had, and that's what we would do if we were finishing this, but I'll just continue on for the purpose of time here. Let's address some of these other warnings. So we can see that this model contains annotation mismatches. And if we click on more help for this, right, it's going to tell us exactly what to do. So it's going to say we want to go to the manage annotations, and then from there we can address our annotations. So I'll close out with that and go to our manage annotation and go to our mismatched. And I believe it's on a different combination state here. Yeah, so it's referring to this guy. And what we can do is we can click on that and we can update that selected. And it's automatically going to bring in that 4 times, correctly referencing those 4 holes here. Okay. Now, the last one we're going to do here is this model contains unvalidated annotations. So if we go back to our other combination state here, and we click on actually, let's just go to more help. And again, it's telling us to go to manage annotations. So we'll go ahead and do that. And we can see that we have some unvalidated annotations. So as I click on this, it'll highlight which ones are unvalidated. And I can go ahead and address this. Now, as I'm noticing this, it says that this surface is constrained by that profile note, but it's not fully constrained, which we probably would want to fully constrain that to validate that 4 places dimension. So what we can do is we can create a new tolerance feature. And we're going to select all 4 of those flat surfaces. And instead of a geometric tolerance, I'm just going to do a size dimension. And the nice thing about GD&T Advisor is that it can reference what that actual dimension is, and we can just hit one button, say auto match, and it'll bring in that value of that board depth, right? So the green check mark is now available to us. We can go ahead and click OK. And now in our constraint state, we can see that these surfaces are now fully constrained, and that warning message went away. So overall, GD&T Advisor is a great tool, not only for MBD, but just for modeling in general. If you are unsure about your creation of GD&T, unsure about the validation, and if your symbols are done correctly, GD&T Advisor is a great tool for all of those things. All right, so we're going to exit out of this. And now we have our completed model. So we have this completed product defined fully by model-based definition. Now, how do we export this? If this is going to be our legal asset, we got to have some way to view that. And of course, we could print out each one of these combination states just as a PDF. That'd be one way of doing it. But kind of a better way of doing it, especially in the digital transformation perspective, is by exporting this to a Creo view file. So if we wanted to do that, we would just go to Save As, save a copy. And then for our type, we can pick Creo View, PVZ, or any of these types here. Okay, so I'm going to go ahead and open up Creo View. We'll see what this part looks like inside of Creo View. Okay. Oh. All right. So in here, under the Viewables tab, we can see we have all of our combination states in here. And like I said, with Creo View, there's a few tools in here that we can use. So let's say we wanted to maybe take a measurement, measure the length of something. We could easily do that. We could easily measure the diameter of a hole, right? We wanted to measure the diameter of that. We could calculate mass properties for this entire thing and do some other cool markup tools as well. Now, when it has to do with digital markups, right? The goal with MBD is to kind of get rid of the 2D manual paper print process. So what we can do with Creo View is create these digital markups. So let's scroll through here and see if we can find anything that we want to mark up. So for this state example, for example, we have this datum in here that probably doesn't need to be in here. So what I can do is I can grab this guy, put a box around him, add a note. Add a note in here that says maybe remove datum from combination state. We can add a leader to that as well, creating that digital markup. Maybe I wanted to add one more here that says, for our engineer, maybe double check with tolerance or something like that. Then add a note to, or a leader to that note as well. So we can create these markups, and honestly, it's probably a lot faster to do it on the computer than it is to do by hand. And from here, let's say we wanted to save these markups. We can go ahead and save that annotation set. And I'll just call it markup. And now if we go to our annotation sets, we can see that that markup is saved. It's trackable. It's not going to go away. We're not going to lose a piece of paper and try to figure out, what was actually marked up. It's all digitally saved and trackable, which is definitely a plus, especially in today's day and age where we have engineers working from home. We have multiple people who are collaborating over Skype and Zoom calls and things like that, being able to take model-based definition and take these parts, being able to annotate them and revise them all digitally is definitely very powerful in today's industry. So that was kind of it for the demonstration portion. I am going to go back to the PowerPoint quickly, but before that, I did want to pause for questions if you guys did have any questions at this time. And I haven't really been checking the chat, so.
There is one chat. Says, what are best practices to build out MBD with regard to suppliers and vendors who don't have the current capabilities to handle this type of work? For instance, the people on the factory floor might not have tablets or computers and need 2D prints.
Yeah, that's a good question. And to be honest, it's MBD is a process, right? We need to, in order to incorporate it, we need to address these type of questions. And really, I think the best way to go about it is to reach out to your supplier, reach out to your shop floor workers, and figure out the best solution that works for everyone. And obviously today there are still a lot of machine shops that are using manual machining tools that a model would be nothing to them, right? But as industry grows, as we're moving towards the future, the model will be the source of truth for the product definition. And I think the rest of the processes will kind of work themselves out as technology increases, as these processes are getting more efficient. So hopefully that answered. But yeah, there definitely are still some discrepancies between MBD and downstream activities. But I think, like I said, in the future, that gap is going to be closed more and more. And if you can get ahead of the curve by having these model-based defined products, I think the transition is going to be much easier for you.
So when you exported out of Creo, there were 4 different selections, and you chose the PBZ.
Yeah.
What's the difference and why?
To be honest, I'm not sure what the other ones are. They're all Creo view files. I've only used PBZ. I'm really not sure. That's a good question. I'm not sure what the different file types encompass, but I know that the PBZ allows you to do everything that you want to. So I think by default I would use PBZ, but I think that is a good question on kind of the other types and what they're doing. But I'm not sure.
Okay.
So before release, a reviewer needs to click on every single feature to make sure that it has the correct references set for downstream tool use.
So no, that's not exactly necessary, I would say.
Well, if I have a tool that's reading all the semantic references, who's making sure that they were entered correctly?
So I guess if you do have a tool that is using those semantic references,
or even even a team, like a use case, right? So if a team is relying on properly set up semantic references, then somebody needs to go in and review that, in which case the reviewer would then need to go into the model itself and then click on every single one to make sure that semantic references are properly set up.
Yeah, I mean, I do agree with that. I think the same thing can be said about the actual geometry of the part, right? You have to review that it's correct. You have to review that the annotations are correct, that the part is set up for manufacturing and for downstream processes correctly. So I think it is an extra step, but it is necessary to review those to make sure that if the downstream tools are using those semantic references, that just needs to be done.
I also noticed that you didn't mention step files. Is that not recommended at this time?
So step files are fine, right? If you have I know a lot of machine shops with those newer CMM machining tools use step files, and that's totally fine too. You can export this model as a step file. And, I think the thing is when you're using a 2D print and you're not verifying that your model is set up correctly, sometimes you may, fake an annotation on the 2D print and your geometry doesn't accurately represent that. So obviously step files are fine. And I think MBD just helps you verify that your geometry is correct.
Because I'm not sure if step can do flat to screen annotations. So I think
Sorry, I
you
can't
have
really.
to-
Could you repeat that? I couldn't hear you there.
Sorry, I think step files can't do flat to screen annotations. Well, so if you're exporting, like we just had this issue where someone was exporting a product and it was showing every single annotation at the product level, especially I'm not sure every annotation or definitely the flat to screens were showing up in submodels. What's the recommended practice for like product level step exports versus MBD part level step exports?
Yeah, so that's
Typically it's a one setting, the admin's gonna set it once, set and forget, whereas here you have two use cases. You kind of don't want MBD at higher level assemblies
right.
coming from lower level parts.
Right. Yeah, and I think that's a very good point. And right now, I actually just was at a meeting with PTC last week, and they admitted that some of the exporting is not exactly ideal for MBD at this time, but they're really making a push for the newer releases of Creo to have that added competency and added capability of being able to export these models and retaining those annotations. But right now, there's not a great solution for that, unfortunately.
Thank you.
All right, all those questions were great. Thanks, guys. Are there any other ones before we continue on here? I really only have about 5 minutes left of slides, so feel free to speak up if you have any questions. I will take the silence as a cue to move on. All right. So for this slide, I'm going to kind of walk through a maturity matrix of model-based definition. And I want you guys to just think about where you are and maybe where you'd like to be in this maturity matrix as it refers to model-based definition. So the first one is drawing centric. And this is where we only have the 2D drawing. We don't even have a 3D model. And actually, we still work with a lot of customers who are still in this state where they're just doing everything in 2D still, which is fine. But I think those companies are going to need to, start changing the way that they define their products. So we have the drawing centric, we have model centric, which is probably where 95% of the people I work with lie, where we have a 2D master drawing. That 2D drawing is the legal asset, but we also have an associative 3D model. Now, this model is not verified, or it is verified, it is verified and configuration controlled, but we're still using that 2D drawing as our legal asset. And when that happens, honestly, we still might have discrepancies between the 2D drawing and the 3D model, especially if we're not taking the correct practices and not making sure that our dimensions are correctly verified. And then finally, we have what we're talking about today, model-based definition, where we're only using our CAD data. We can generate our 2D drawings if they're needed, but they're derived directly from our model. And then the last step in this maturity matrix is the model-based enterprise. So using this 3D model as that source of truth, fully leveraged by the enterprise and the other downstream activities. Now, obviously, PTC's PLM solution is Windchill, and there's a lot of great tools in Windchill that help with creating a model-based enterprise. So there's a lot of tools within Windchill that will take this model, all the information of it, and help to use that for downstream activities. For example, BOM transformation, work instructions, things like that, quality information. That's where the model-based enterprise is. So I think in the future, we're going to be seeing a lot more model-based enterprises. And, the sooner you can get familiarized with model-based definition, you're going to be ahead of the curve for industry as it moves forward in technology. All right. So with model-based definition, the companies that have incorporated it, 84% of their products achieve revenue, cost, launch, and quality targets by using model-based definition. So I just wanted to put this up here that says, using model-based definition and the companies that have incorporated it, it's overall been a success. Obviously, like we talked about, there's still some things that need to be improved, especially with the exporting of our models and kind of the communication in that regard. But, the companies that are transitioning to MBD are finding success. And then finally, last slide here, we have some of the big customers that have fully committed to MBD. And you can see some of the names on here, some really big companies: Boeing, Lockheed Martin, Raytheon, General Dynamics, Toyota, Rolls-Royce. All these members of the ASME committee have fully committed to MBD. So as these, kind of these larger driver companies are committing to MBD, we're going to start seeing a lot of the, the feeder companies, the smaller companies, start to transition that as well. So I think the sooner you can get familiar and start incorporating MBD processes, you're going to be ahead of the curve, and you're going to be more successful when, more of the companies start transitioning to it. So that's all I had today. I really appreciate you guys attending and listening to me ramble on about model-based definition. So with that, are there any other questions before we sign off?
Thanks, Stephen. I don't see anything more on the chat. So here's your information everybody can see. Are you based in Illinois? I don't know.
Me, I'm actually from Wisconsin. I live right outside of Milwaukee.
Okay, good, thanks. Yeah, I've got nothing else. I would hope everybody has a nice holiday season. And as far as Badgerland, yeah, we will try to get that recording up this afternoon, and EAC may be able to put it on YouTube, and Badgerland will try to put it on YouTube also, and then we'll have a link on LinkedIn and Facebook groups. And then our next thing is January 13th. Rand is talking about sheet metal. So thanks, everybody. Have a good Christmas.
Yeah, thank you.
Thanks, everyone.